choose from.
Hello, everyone. We'll start in a minute, right? Start in a minute. All right, let's get started then. Again, if you guys can open up your cameras, that'd be awesome, but not required. Let us begin then. So, was everyone able to download the package and install the get through the installation process? Or if you weren't able to, did anyone meet any problems with it? Problems later. Did anyone get any problems? Any problems? All right. If not, it's perfectly fine. That's great, actually, if not. But if any problem does come up, make sure you let me know. So today we're going to be going over the data structure lesson, the unit for binary search and recursion. So what I'll do is I'll basically just go over what the content is, the topics, and then go over the code, and then at the end talk about how you want to structure your class when you're teaching it. All right. Now, obviously, I'm going to be going a bit faster or a lot faster than how you should actually pace it when you're teaching the class. Though in any case, let's get started. So let's start with the first topic, binary search. Yeah, this is going to be the first unit you're going to be teaching. And then to start this, you basically start with the activity, a quick activity for your students. I mentioned this last meeting, where you think of a number between 0 and 1,000, and then you want the students to guess what the number is, and then they'll try to do it in try to do it as fast as possible. So they'll guess a number, and you tell them if the number is higher or lower than that number, and you keep going. And you can see how this includes binary search, right? Because usually intuitively, you can think that the fastest way to get there is by first go for 500, right? Because that's half of it. And because by doing so, you essentially eliminate half of all the wrong choices. And you keep going, maybe 250, then 300, whatever, right? So this is meant to be a lead in to the binary search topic. And I highly recommend, going through this with your students or most of your students. It's a fun activity to do. And two, you can use this to talk about how binary search work really easily, right? You first basically you find the starting point, the ending point, and then you find the middle point, and then you compare the value at the middle point to the target value, see if it's higher or lower. If it's higher, you guess if the target value is higher, you guess the upper half. If target value is lower, you guess the lower half, etc. So this is a nice lead in. Now, when you go over this activity, though, make sure when you're teaching it to actually make that connection. It's not enough to just play this game and then that's it, right? Make sure you make that connection between how this activity connects with how binary search actually works. And the next up is a quick calculating the binary search time complexity. Yeah, you can see that the time complexity it's O log n, and how you can get this, and what's listed here is one way you can think of to get to that point. It's all animated, by the way. So if I click present, right? And the idea should be pretty intuitive. You see that at k iteration, assuming at the kth iteration, you're left with only the length of a race left is 1, and you know that at n over 2 to the kth power, that's equal to 1, right? Because if you just go through it after the first iteration, you eliminate half of the length of the array. You eliminate half of the array. The second iteration, you eliminate the half of that half. So you eliminate n over 2 to the 2 squared. And you keep going until you get to n over 2 to the kth power. So at the kth iteration, you leave it with 1. And you can find out what the time complexity is by doing a quick logarithmic calculation. Now for time complexity, when you're teaching this, you don't have to go through, what is it? Yeah, you don't have to be too in depth about this. Right? This is just meant to be introduction. So go over to your students, see if they understand it, and yeah. So that's the concept, introduction to the concept of boundary research. Next up is just the code, right? The code is the majority of the class. It is going to be the more important part of the class. So let's go over that. You open up the code as usual, cd to the right notebook, and then type in Jupyter Notebook. All right. Binary search, part of the binary search, you start with just binary search by itself. You just start with binary search. You're given a sorted array, right? And then you're given a target value, and then you want to find out the position of that target value in that sorted array. And to do that, here's the solution code. It's all posted in the Syncline. It's not what I'm supposed to press. It's all in the Syncline Start Here classroom. Yeah. So I'm going to go over the code first, and then at the end talk about how you should approach teaching this. All right. So if you have touched binary search before, this should be pretty familiar. You first initialize two variables, the starting index and the ending index. The start variable, represents the starting index, which is 0, and then end is the lambda length minus 1. While start plus 1 is smaller than end, so this means while you're still looking through the array, right? Because the moment the starting index is greater than the ending index, you know that you've looked through all of the array for that number. And if that number is not in the array, you know that it's still not in the array. You know that this number, the target value, the target number is not part of the array. So while this is looping, you find out what the midpoint is. This is the equation to find the midpoint. It's the same as just start plus n divided by 2, except by doing it this way, you prevent overflow. If the midpoint is equal to the target value, then you got it, right? Then you just return what the midpoint position is. That will be the position of the target value. If it is not, what you do is you set the, if the midpoint is smaller than if the midpoint value is smaller than the target value, you set the starting index equal to the midpoint. This should make sense intuitively, because if, let's say, you can relate it back to that example before, from 0 to 1,000, right? If the number you're thinking of is 700, 700 is greater than 500. So then you can set the starting value from 0 to 500. You essentially eliminate half of all the arrays, and you now look at the other half, right? And then you do that, and you keep going, find the midpoint again, and you compare it again, and all that. And then once you go over this loop, you can you'll basically come to find out what the position is. And if, like I mentioned before, if after the loop finishes, you still haven't found out what the position is, and you know that the target value is not in the array, then you return -1. Yeah, so that's a really brief explanation of how binary search works. Any questions so far? Now, when you're actually teaching this, you're gonna have to be a lot more in depth than what I'm doing. I really recommend going through a few examples. Like, just go through this example with your students, like how it works step by step. I'm just covering it really quickly because we had to go through a few problems today. All right. So when you're actually teaching this with your students, be more specific than what I'm doing here. Another thing I want to mention is, when you're teaching this, as I mentioned before, you want to start by just start on your screen with just a blank template, and then write it down line by line while you're explaining it. And then at the end, when you're done explaining it, then ask your students to recreate what you just done. That's the teaching approach you should be taking. All right. So this is binary search. If there are no more questions, I'm going to move to the next one. I highly recommend, no, not recommend, just make sure before you teach this class or before you teach any class or just after this meeting today, look over the code on your own and try to just do it by your own as well. You want to make sure you understand it, right? Just go through it, look through it step by step and see if it makes sense. If it doesn't make sense, let me know, questions or whatever. Yeah. The next problem is going to be first position of target. This is really similar to binary search as well. No, this is just, sorry. This is binary search, except in the previous example, you see that if the moment we find the position of the target value, we return that position, right? In this case, what if the sorted array has repeating values in there? And this problem asks us to find the first position of the target value. So if we're looking for the number 3, right? The output should be 2, index 2, not index 3, because the first position of the target value is at index 2. And how does the code work? It's the exact same as, it's almost exact same as the binary search algorithm, except whereas in the binary search algorithm, the moment you find the midpoint value, you return the midpoint value. In this case, if you find the midpoint value, you don't return it yet. You set the endpoint equal to that midpoint value, or if the target value you find is if the midpoint is greater than or equal to the target value, you set the target value, you set the endpoint equal to that midpoint. And this way, basically you'll be iterating through the process. You'll be iterating through the entire array until you get to a point where there's only 2 values left in that array, right? Where the starting point is just start plus 1 equal to end. That's how the while loop breaks, right? And when that happens, you realize that if the starting value is equal, either the starting value is equal to the target or the ending value is equal to the target, and one of these two targets has to be the first position of that target value. Otherwise, if it's not here, then it's not going to be in it's not going to be a part of the array. You can just return -1. You can see this more intuitively by just actually going through the loop here. You can just look through this array here and then try to see how it works. So let's see, there is 3. So this is the midpoint, right? You have seven values in here. This is the midpoint. And then, yeah, in this case, as you can see, you set the end. So because the midpoint is equal to the endpoint, sorry, the midpoint is equal to the target value here, what you do is, what you realize is this condition is true, right? You set the endpoint equal to the midpoint. So this becomes the endpoint now. It's not what I'm meant to do. This becomes endpoint now, and then you find out the midpoint again, which becomes 2 here. And then you just keep going, and then you realize you will eventually shrink down to an array where the start point is 2, end point is 3 in this index. And then you see that, all right, the start point is the start is not equal to the target value, but the end is. So that's going to be the first position of the target. Any questions? All right. Again, look through it on your own. It makes more sense once you just go through it by yourself as well. All right. Now the last one, this one is a bit more complicated than the previous two. Searching through a rotated sorted array. So in the previous cases, you're given a sorted array like 0, 1, 2, 5, 7, 9. In this case, you're given that array, say 0, 1, 2, 4, 5, 6, 7, but it's rotated. So it becomes, 4, 5, 6, 7, 0, 1, 2, right? It's rotated. The problem is still the same. Given a rotated sorted array, and then given a target value, find the index of that target value. All right. So how do you do this problem? The idea is still the same. It's still binary search. However, you notice that there are 2 parts to the array. There's the first part, the part that's been rotated, and the second part, the part that's not rotated. So to solve this problem, basically what you do is you break this problem into a few different cases. The first case is right here. See, all of the beginning stuff is the same, right? But the first case, this line, is if the midpoint you look at, if the midpoint, which is just a regular midpoint, the start plus n divided by 2. If the midpoint is is in the first part of the array or the rotated part, so in this case, it'll be 4, 5, 6, 7. If the midpoint is in this array and the target value is also in that first part, then you just do binary search on that first part of the array. If the midpoint is on the second part and the target value is on the second part of the array, you just do binary search on the second part of the array. Otherwise, in this case, you catch another case is if the midpoint is in the first part of the array, but the target value is in the second part of the array, you set the starting point. You set the starting point equal to the midpoint. So you're basically pushing the starting point closer and closer to the target value, since you know that the target value is in the second part of the array or the later part, right? And then in the other case, if the midpoint's in the second part and the target value is in the first part, you do the opposite. Now, how do you find out whether or not a value is in the starting array? Is in the if the value is in the first part or the second part of the array? You compare it to the very first number of the array. If the number you're looking at is greater than or equal to the first index of the rotated sorted array, then you know that it's going to be in the first part. It's going to be in the part that's rotated. If the number you're looking at is less than the first index of the sorted array, then you know that it's going to be in the second part. And this should make sense, right? It's if the second part is a part that's always going to be smaller than the first index because it's rotated. What it should look like is the regularly sorted one will be 0, 1, 2, 4, 5, 6, 7, but now it's rotated. So that's by comparing it to the first index of the rotated sorted array, you find out whether or not the value you're looking at is in that array, is in that part of the array. Let's see. And yeah, and as I mentioned before, if both of them are in the same part of the array, you just do regular binary search on it. Yeah. Any questions? All right. Again, make sure you look through this on your own as well. Just go through each cases. I think looking through specific examples definitely help. Actually really helps. Just take a few examples here and try to do it on your own by hand using this process, and it'll make more sense. All right, so that's the searching rotated sorted array, and that's basically binary search. Now, as you probably saw, I went through all of this in like 10 minutes. But in reality, this can take up like quite a few classes actually, just this stuff right here. So when you're teaching this, when you're pacing this class, don't rush at all, right? Just go through it once with the students, let them try to recreate it. And then once that's done, if they get stuck, which they probably will get stuck, go through it again, or just go through the part they're stuck on, do that repeatedly until they get it. Don't just give them the solution. That's never helpful. By don't just give them the solution, I mean, don't just let them copy down what you have on the screen. All right. Yeah. And also for a few cases, like for the, if you haven't noticed, for the first position of target, the product here is really, the code here is really, really similar to the binary search one, right? It's just a one-line difference. So if you think your students can handle it, feel free to just let them try it out on their own first without you going over anything, except that just going over what the problem is, right? If you think they can handle it, just go over what the problem is and then just let them try to see if they can figure it out. Each class is different. There are obviously different approaches, but yeah, that's that. Special cases. Let's see. All right, so that's binary search. If there are no more questions, I'm going to move on to recursion. So recursion, this is the second unit. The idea is, basically the idea is you are breaking down one big problem into smaller problems that can be solved with a similar principle. Right, so such as the Fibonacci sequence. So how does Fibonacci sequence work? Fibonacci sequence is the other than the first and second index are going to be the number 0 and 1, and every number after that is going to be the sum of the previous two numbers. So it will be 0, 1, 1 because 1 is equal to 0 plus 1, 2 is equal to 1 plus 1, etc. Sure, you've all seen Fibonacci sequence before, and this is a perfect example of how recursion works, right? You basically break down one big problem into smaller subproblems. The what is the nth index? The nth index is just the n minus 1th index plus the n minus 2th index. What is the n minus 1th index? That's a sum of the n minus 2th index plus the n minus 3rd index. Right? You're breaking down one problem into smaller subproblems. Now, a few things about recursion. There must be a base case. So a base case in this case will be, if n equals 0, it's equal to 0. If n equals 1, it's equal to 1. You return 1. Otherwise, without a base case, this is going to repeat over and over again. Recursive algorithm must call itself recursively. That just means this line right here, right? You need to call its own function. And then it must move towards a base case. So as you can see here, whatever n is, so you're subtracting n by 1 and 2. So it's moving towards a base case of 0 and 1. Right? If n is, n plus 1 or n plus 2, that wouldn't work because it's getting bigger and bigger and bigger. It's never going to reach the base case. That's recursion. Again, really brief explanation. That's how basic recursion, and let's look at the few problems associated with that then. So there are 4 problems we have associated with recursion. The first problem, we have Fibonacci number. As basically what I just mentioned before, Fibonacci number, right? If you have 2 base cases, if n is equal to 0, return 0. If n equals 1, return 1. And then for every following index, you just find out what is the n minus 1th number, fifth number plus n minus 2th number. All right, so that's Fibonacci number. It's just that. Climbing stairs as the next one. This is also really similar to how Fibonacci number works. And the problem here is you are climbing a staircase, and then it takes n steps to reach the top. Now you want to find out how many ways it takes to climb to the top. Now you can either climb 1 step or 2 steps, right? So then you find out, okay, well, how many different ways you can climb to the top. So let's say you want to climb to the 3rd step, right? How many ways you can get there? You can either just all take steps of 1, so 1, 1, 1, or 1, 2, or 2, 1, right? So then there are 3 ways to climb to the top. That's this example right here. So how do you solve this problem recursively? Really similar to Fibonacci sequence, you realize that, all right, to find out how many ways you find out how many ways you climb to the nth stair, you find out how many ways there are to climb to the n minus 1 stair, and how many ways there are to climb to the n minus 2 stair. Because the stair level n minus 1 and stair level n minus 2, these two are the only ways you can climb to. You have to climb to these 2 stair levels to get to the nth level stairs, right? Like to get to stair 4, so stair level 4, you have to get to stair 2 and stair 3, or stair 3. Because if you get to stair 2, you can just, take 2 steps to get to stair 4, or if you get to stair 3, you can take 1 step to get to stair 4, right? And how do you find the n minus 1 stair? You find the n minus 2 and n minus 3. So really similar to Fibonacci sequence, you just break it down like that. Now, for recursion, when you're teaching this, I really recommend just going through the subproblems with them, going through different cases with them, like just literally do it by hand, what n equals 4 looks like, right? It makes more sense to see it using an example than just saying it conceptually. All right, so that's climbing stairs. Now let's look at a few of the more difficult ones. So one, we have the Tower of Hanoi. I'm sure if you've done recursion before, you've probably seen this problem. Basically, you are given, here, let me pull up an image actually. Right, you're given 3 pillars with a stack of plates. And then you basically want to move all of the plates from stack A to from pillar A to pillar C. A few rules you have when you're moving these pillars. The pillars, number 1, you can only move one plate at once. you have to move it from the top to the top of one pillar to the top of another pillar. And you also have to ensure that the smaller plates are always on top of the bigger plates. Right. So that's basically the two rules of the game. And then you want to find out how you can move how you can move all of the plates from stack A, from pillar A to pillar C. So in this case, how you can move all of the stuff from here to here. All right. So to solve this problem recursively, what you need to do is you need to realize that this big problem can be broken down into smaller problems that follow the same principle. And what is that same principle? To move the plates from one pillar to the other pillar, you first, let's just use this as an example. Let's use this as an example, actually. You first move everything other than the bottom plate to the second plate. Let's call that to the second pillar. Let's call the second pillar the other pillar. Right? You have the starting pillar, the target pillar, and I just call it the other one. So you move the everything but the bottom plate to the other pillar, and then you move the ending plate, the bottom plate, to the starting to the target pillar, and then you move all of the pillars to the target pillar. Right. So that's the basic principle. Here, actually, I don't want to try that. I don't have a pen here right now. But yeah, that's the basic principle. Yeah, basically like that. And now you realize that, okay, how do you move? So then how do you move the top two plates to the other pillar? Well, you do the exact same process. Now this other pillar then becomes the target pillar for those two plates. So then you move the top plate or everything but the bottom plate to the other pillar, move the bottom plate to the target pillar, and then move the plate back. And then you go through the process again, right? So you just break down this one giant problem into smaller problems using the same principle. And that same principle is move the top plates to the other pillar, move the bottom plate to the target pillar, and move the rest back to the target pillar. And you can see this idea here. If there's only one plate, you just move the plate to the target pillar, right? You just move C1 to C3, move from pillar 1 to pillar A to C. However, if there are more than one plates, you first move everything but the first pillar, but the bottom plate, right? Everything but the bottom plate to the other pillar, right? Because if you look at the code, you move everything but the bottom pillar to the other pillar, and then you just move it back, right? You move the other plate to the target pillar, and then you move it back. Does it make sense? Any questions so far? I think, yeah, it just makes, all right. So that's basically it. You just break the one big problem into smaller problems. Again, I recommend going through this with like smaller examples. Yeah, when you're actually teaching this, use examples like what it would look like by hand if you use 4 plates, right? You need to first move the 4 plates, you move the top 3 to the other pillar first, but then how do you move the top 3? Move the top 2 to the other one, and so on, right? Yeah, use examples. That helps with understanding this. All right, so that's the Tower of Hanoi. Yeah, and let's move on to the final one, predict the winner then. Predict the winner. So in this case, what the game is, you're given an array, and then what you want to do is you're given a big array, and then you have 2 players. Player 1 starts. In both players start with a score of 0, and then each player can take one number from either end of the array, and then but literally take it. So by doing so, you reduce the size of the array by 1. And then that player takes that chosen number and adds it to the sum, adds it to the score. And you just keep doing that until there are no more elements in the array. You take all of the, basically took everything from the array, and then whoever has the highest sum or highest score wins the game. So in this case, you want to see that, all right, assuming two players are playing optimally, how do you find out? You want to, given that array, find out who's going to win. So if player 1 wins, you return true. If player 2 wins, you return false. Right. So an example, we have 1, 5, 2. You'll see that initially the player can choose between 1 and 2. If either one chooses, if player 1 chooses 1 or 2, player 2 can choose 5. So in both cases, no matter what, player 1 is going to lose. So return false. All right. So how do you do this problem? Just break it down into different cases. So you are given this array of numbers. What you need to do is you need to find out what the you create a helper function with the array nums. The integer L and R. L and R represents the left index or right index you're looking at. The leftmost index that the player hasn't chosen yet. The rightmost index that the player hasn't chosen yet. Because remember, every time you pick a number, you basically remove the number from the index, from the array. We're not actually going to modify the array, so we use these indexes, L and R, to keep track of where we're currently at. And someone is going to represent the score of player 1 and sum to the score of player 2. And player represents whose turn it is. If it's 0, it's player 1's turn. If it's 1, it's player 2's turn. So if left is greater than right, the leftmost index greater than the rightmost index, then you know that we've looked through the entire array. All of the numbers have been taken out already. So then we just return whoever has the highest score. Now here's where it gets interesting. To find out if player 1 wins, you just break it into cases. If it is player 1's turn, player 1 can either pick the leftmost number or the rightmost number, right? If they pick the leftmost number, you add 1 to L, right? Because it's the player 1 picked that number, and that's how you move that number. And then player 1 adds that number to their sum. And if the player 1 picks the rightmost number, you minus 1 from the right side, and then you add the number to the sum. As long as this function, player 1 can only win as long as either choice he makes it returns true, or either choice he makes brings him the higher sum, right? Because player 1 just needs to win. So if he picks left index or the right index, as long as either one can make him win, he wins. However, if it is player 2's turn, exact same thing, right? Player 2 makes a choice. And player 1, if it's player 2's turn, right? Player 1 can only win if either choices that the player 2 plays leads to player 1 being the winner. Because remember, in both cases, the players are going to be playing the most optimally. So in this case, player 2 is going to try to play in a way that allows them to win. So player 1 can only win if no matter what the choice player 2 plays, player 2 is going to lose. And that's basically it. You break this down into 2 cases, and you see that, all right, so if you have a bunch of different numbers, and recursion just basically solves all of the problem for you. You have a lot of numbers, and then player 1 picks a number, the second player 2 picks the next number, and so on and so forth, and then it keeps going, right? And then the recursion, basically the algorithm moves towards the base case as L increases and R decreases, moving to L greater than R. And then you see if someone greater than or equal to sum 2. And then by doing so, you basically go through all of the different cases recursively. And that's to predict the winner. Any questions? All right, so yeah, that's basically recursion. Again, I am rushing, or at least going through it a lot briefer than when you're actually teaching what you want to do. Um, when you're teaching it again, just go through the code, write it all out for your students, and then just explain it. And then really recommend going through specific examples, right? Like just go through what it looks like, running through that algorithm by hand. What it would look like if you like place with this, let's say place with this array right here. What will happen? Helps with understanding. All right, yeah, and that's it for recursion. Let's see. All right. Yeah, so let's see. Next meeting is going to be Friday. Next week, next meeting, I'm going to go over dynamic programming. And maybe I'll go over 2-pointers as well. We'll see. All right. If there are no more questions, that'll be it for today. Thank you all for coming. Bye.